let's now introduce the difference of perfect squares. Okay, so this is a very common technique and it could be tricky, but the more you practice it, the more you master, right? The faster you master. So, what this technique says is that first of all, you have to have a quadratic polynomial. How do we know we have a quadratic polynomial? Well, you look at the polynomial, and if the variable, which in this case is x, has a 2, is it on the to the power of 2, then it is a quadratic polynomial. Well, that's the first step. Second, it has to be in the shape of decreasing the power. What do I mean with this? We have x squared, then we have a term with only x, which is x to the 1, and then we have a term without x. So you see that the power is decreasing by 1 in every term. So we usually take the quadratic polynomials as the shape of ax squared plus bx plus c, where a, b, and c are numbers. Okay, so you can see here this has a 1, so it's a number. This will be a for us, this will be b for us, and this will be c for us. Okay, so how do we factorize this polynomial using the difference of perfect square? Well, the first thing that you need to do is to find two numbers that multiply, give me this value, so give me c, and add it or subtract it, give me 2 or b. Okay, so we need two numbers, one number and two numbers that multiply, give me c, and these same two numbers that when they are added or subtracted, they give me b. What is the easiest way on how to find this? Well, we take c, the c term in this case is minus 80, and we decompose this number. How do we do this? We find all the numbers that can be multiplied and will give me minus 80. In this case, let's only take the 80, then we deal with the sign. So let's see. We have 80. 80 can be a result of, and then we start. My advice is for you to start with the number 1, right? So you have 1 here. To what number do we have to multiply 1 to get 80? Itself, right? 80. 80 times 1 is 80. Then we go to 2. What number do we have to multiply 2 to get 80? 40, right? 40 times 2 is 80. Then we go to 3. Is 80 divisible by 3? No, right? So 3 doesn't count. Okay, now let's do 4. To what number do we have to multiply 4 to get 80? Well, we have to multiply it by 20, right? 20 times 4 is 80. Then we go to 5. To what number do we have to multiply 5 to get 80? 16, right? So we have 16. 16 times 5 is 80. Now we go with 6. Is 6 divisible? Is 80 divisible by 6? No, right? So then we go to 7. Is 80 divisible to 7? No. So now we go to 8. Is 80 divisible to with 8? Yes, right? So 10 times 8 is 80. And now we start evaluating these numbers. You can keep going. You will find a way that you cannot combine any more numbers to create the number 80. But it's good for you to understand how you can do all this for you to find these two numbers. So now let's see what of this combination we could use that added or subtracted we will get 2. Okay, so for example, we have 80 and 1. Is there a way that we can add 80 plus 1 and get 2? No. Or subtract 80 minus 1 and get 2? No. In this case, 40 and 2, no. 20 and 4, no. 16 and 5, well, 16 plus 5 is 21, so no, that's not 2. And 16 minus 5, that's 11, so that's not 2, so it doesn't work either. And the final one, we have 10 plus 8, that will be 18, that's not good. But 10 minus 8, that will be 2. And we have the number that we want. We wanted 2. Okay, so now what we need to do is to put these two numbers in two different parentheses. The way we do this is we put x and x. How do I know that it's only x in both? Well, because here is x squared, which means that the factorization has to be a degree less than what we have previously. Okay, so because when we develop this factorization, we do the distributive multiplication, then we end up with x squared. So this x squared, we divide one x here and one x here. And now we write down this number. We found that it was 10 and 8. Okay, so now let's think about the sign. We have a negative sign here and a positive sign here. But we know that these two numbers have to be subtracted to each other to get 2, right? Because if they are added, then we get 18. And that's not in our interest. Okay, so for a multiplication to be negative, at least one term has to be negative, right? And for the difference to be positive, then the greatest term or the largest term or number has to be positive, right? So in this case, we have 10 and 8, where 10 is greater than 8. So 10 is positive and 8 is negative. How do I know this? Well, you can check your work. You can do plus 10 minus 8. This will be plus 2, which is the one that we want. And 10 times minus 8, this will be minus 80. And this is the term that we want. Also, the good thing about factorization is that if you have time in your test, you can always check your work, right? So how do you check your work? Where if you apply the distributive property here, right? Term by term by term, then you should get the initial polynomial, okay? So now let's keep practicing this method, the difference of perfect square, and now let's do this one, x squared plus 6x plus 9. Okay, first thing to do is to take two numbers that multiply, give me 9, and add it or subtract it, give me 6. Okay, now we take 9 and find two numbers that can be multiplied to each other and end up with 9. So we start with 9 itself, 9 times 1, then we have 2, but 9 is not divisible by 2, so that doesn't apply. Then we have 3. 9 divided by 3 is 3. Then we have 4. 9 is not divisible by 4. Then 5, 6, 7, and all of that is not applicable because 9 is not divisible by those numbers. So we only have these two options. Let's analyze the first one, 9 plus 1, that will give me 10. No, we are not interested in 10, we are interested in 6. 9 minus 1, that will give me 8, so none of these work. 3 plus 3, that will be 6, and that's the number we need. So what do we do now? We open two parentheses. Remember, it's the amount of the number at the greatest power here. We have two parentheses, x and x, and we write down these two numbers that we found, 3 and 3. How do we do the sign? Well, we know that we have plus here and plus here, and we know that these two have to be added to each other. Okay, so for two numbers to be added and give me a positive number, is either the greatest number has to be positive or both of them have to be positive. So, and to get a positive multiplication, we either multiply minus times minus or plus times plus. So in this case, both of them are positive because we have 3 plus 3, and that will be positive 6. And we multiply 3 times 3, and that will be positive 9. So we got the two numbers that will give me the factorization of this polynomial. Okay, so an additional information here that is important is that when we have these two parentheses, for example, in this polynomial and in this polynomial, these numbers are exactly the zeros of the polynomial. How do we know? Because if we equal each parenthesis to 0, for example, let's take this first example that we did. Let's take x plus 10 times x minus 8. And now we take each parenthesis and equal that to 0. So we take x plus 10 equals to 0, then x is equal to minus 10. So x equals to minus 10 is a 0, and x minus 8 equal to 0, x equals to 8. This is another 0. So we could say that this polynomial has two real zeros. So this function, if we graph the polynomial, if we convert it to a function and we graph it, the function will touch the x-axis at x equals minus 10 and x equals 8. Okay, so this is how we find the zeros of the polynomial. Also, you can recheck if this is valid by substituting the x in the polynomial, and this should give you equal to 0. So let's do that. Let's see if we substitute these numbers, we will get equal to 0. So we have x. So now instead of x, we introduce minus 10 squared plus 2 that multiplied to x. Instead of x, we write minus 10. Then minus 80. And this is equal to 10 squared. That will be 100 positive because minus and minus is positive. Then we have minus 2 times 10 is 20 minus 80. And then minus 80 and minus 20, this will be 100 minus 100, and this will be equal to 0. So it is true, minus 10, it is a 0 of this polynomial. You could also do exactly the same with x equals 8, and the answer should be exactly the same. It should be equal to 0. Same happened with the second example here. In the x squared plus 6x plus 9, we have these two zeros. We have that x plus 3 equals to 0, and 1 0 will be x minus 3. So it means that this polynomial will touch the x-axis at x minus 3. And if you substitute minus 3 in this polynomial, it will give you equals to 0.